Greetings everyone. Today we're going to explore ellipses, specifically graphing and writing ellipses that have been translated. Now, if you're looking for the basics of what an ellipse is, you'll want to see my ellipses at the origin video. So make sure you're in the right spot. So today, the main difference from our previous notes is if we look at that standard form of an ellipse, we are going to pay attention to the fact that we are shifting our x and y values of our center. It's going to look a little more like a circle equation, but the one thing we have to be careful about is now when I describe where my vertices and co-vertices and my focus is, I'm going to have to account for where it began. What was the center number that it began at, and I need to add or subtract from there. So let's start off with our first example. The first thing I want to make sure always that I know it's an ellipse because there's a plus sign and that it's equal to 1. So this is written perfectly in standard form. Let's go through all of our information. Our major axis is taken from the largest denominator. My a squared is 49 and it's under the x value. So the x-axis, or you could say it's horizontally orientated. My center, if it says x minus 3, I write positive 3. If it says minus 5, my value's at positive 5. So let's graph as we do each piece. So my center is at 3, 5. Let's talk about our a value. If a squared is 49, my a value is 7. Now let's graph. A is the distance from the center to the vertex. So we are orientated horizontally, which means I want to go 7 to the east. 1, 2, 3, 4, 5, 6, 7. And I want to go 7 to the west. 1, 2, 3, 4, 5, 6, 7. Now, I physically counted on the graph. I wouldn't have to, right? I'm taking my x value of 3 and I'm adding 7. I'm taking my x value of 3 and subtracting 7. The y value stays the same. So you can calculate without a graph. Let's talk about our b value. B squared is 4, so my b value is 2. B is the distance from the center to the co-vertex, so I want to go 2 north and 2 south. Now, I counted on the graph and could identify my co-vertices, or I could say I'm taking my y value of 5 and adding 2 and subtracting 2. The x value of the center stays the same. Let's connect our dots now that we have all 4 to try and create the best of your ability, a nice ellipse. Hopefully yours are better than mine, of course. Now let's do a little bit of work for our focus. We need to go back to our equation. Our equation for C, don't forget, is a squared minus b squared equals c squared. See my previous video for that information. So I'm taking that 49 and I'm subtracting 4 to get c squared. So c squared is 45, and I need to square root that to solve. So my c value, if I break down 45, let's see, that would be 9 and 5. So 3 square roots of 5. Again, we described that c information in the previous video. Okay? All right. 3 square roots of 5, or a square root of 45, is close to 49, right? So it's a little less than 7. Oh wait, that makes sense. My vertex was a distance of 7. So my focus being a little less than that makes sense. That's perfect. Now, here's where it gets a little bit troublesome, right? I'm changing my x value. My center x value is 3, right? So I'm going to have 2 points. But from that 3, I need to add on 3 square roots of 5, and I need to subtract 3 square roots of 5. That's the x value of the purple dots, the focus or foci that I drew. Now their y values are still the same, right? They're both still at 5, comma 5. So see how I did that? I took the center point, and I'll do this every time. I'll add or subtract the C value. If it's orientated horizontally, I add it on the X. If it's orientated vertically, I add it to the Y. Let's try another one. This time we need to prepare our equation by setting it equal to 1. This isn't in standard form. So we always divide by whatever that value is. So if I write it nicely, I'm going to have an x plus 1 quantity squared over 8 plus the quantity y minus 1 squared over 64, and now it's equal to 1. My larger value, my a squared, is 64 and it's under the y, so that means that my major axis is the y-axis. Think of it going vertically. My center point today, it says x plus 1, I write negative 1. It says y minus 1, I write positive 1. So our center point is right here. A value, a squared was 64, so a is 8. Perfect, square, that's what I want. We are orientated vertically, so I want to go 8 north, and I want to go 8 south. Those are my vertices. So you could draw them, then write them, or you could say, my x value is going to stay the same on both of them from my center. My center was negative 1. And then I'm going to take the y value of 1 and I'm going to add 8 and I'm going to subtract 8. Use those patterns to help you out and make sure that you're correct. Let's talk about our b value. Oh man, b squared is 8. That's not a perfect square, is it? Square root of 8 would be 4 and 2, or 2 square roots of 2. If I try to draw that, square root of 8 is just below square root of 9. So a little less than 3. 1, 2, almost 3. 1, 2, almost 3. See how I drew those? But to write them, let's talk about that. They have the same y value as my center point. Actually, let me color coordinate here. My center y value was 1. We're going to keep it. I'm taking that x value of negative 1, and I'm going to add on 2 square roots of 2, and I'm going to subtract 2 square roots of 2. Look at that. So if your a, b, or c values are radical, take the center and add or subtract from it. That's the extra piece when it's not at the origin that we really have to account for. All right, let's talk about that c value. We need to calculate first. A squared minus b squared equals c squared. So we're arriving at 56 equals c squared. That reduces. 4 fits in 14 times. So c is 2 square root of 14. Okay. Let's talk about how long that is, right? So square root of 56, the closest root is 49. So a little more than 7. Hey, that makes sense. A little more than 7 would be, from the center would be here and would be here. It's right inside that curve, just as it should be. That makes sense. Let's write our points. Now, I'm going to prep my points this time. They both kept their x values. They both had their y value. Let me color coordinate actually. I'm going to keep the same color as my center. Negative 1, 1, negative 1, 1. But from that y value, I'm going to add 2 square roots of 14. And I'm going to subtract 2 square root of 14. Starting at 1, I went down that much, and I went up that much. Now that's written kind of poorly. Let me fix that up a little bit. Sorry. I want you to be able to see that. So we took 1 plus 2 square root of 14. That's a little better. And 1 subtract 2 square root of 14. Now, we never want decimal values. We always want reduced radicals, and therefore we likely will not be able to add or subtract them, and so it will just look like this long expression. All right. One thing I forgot, of course, make sure you connect your dots, show that ellipse to the best of your ability. Hopefully better than mine. All right, for the next section, we are going to work on writing an ellipse. Now, similar to the circles lesson that we did, my suggestion is to prep your answer, meaning ellipses look like circle equations, but they're always equal to 1. All right, so we could prep everyone. If you wanted to pause the video and fill this in on all the writing examples, you could do that. Next, I'm going to determine my center. Now, this is going to be just strictly finding the midpoint. Count the distance vertically, count the distance horizontally. Where is the middle? On a graph, you can just count, and that's totally okay. So from the origin, 1, 2, 3, 4, -4, 2 looks like my center point, right? So I'm going to write x plus 4, and I'm going to write y minus 2. All right, let's figure out our A, B values. This is orientated vertically. That means my y needs the a squared value. A is the distance from the center to the vertex. Let's count. 1, 2, 3, 4, 5, 6, 7. Distance is 7, so I write 49. It has to go under the y because of how I'm orientated. Let's count center to covertex. 1, 2. So my b squared value is 4. So on a graph, you just need to count. But what if I don't have a graph, okay? In these examples, I'm throwing a graph onto my slide here. I would recommend using a marker board or creating some kind of sketch. I think it's very helpful to visualize, to understand the information. All right, no matter what, as I mentioned before, I encourage you to prep your answer. X quantity squared, y quantity squared equals to 1. Now, my vertices are located at 2, 13 and 2, -1. Okay, so if those are my vertices, that automatically means I have a vertical orientated ellipse, right? My co-vertices are at 5, 6, 4, 5, 2, 4, 6, so right here, and -1, 6. So because now I created the same picture as the previous slide, I'm going to approach it the same way. So see how I made the graph very easily? Let's start off by finding our center point. Our center point exists at an x value of 2 and a y value of 6. Hey, take a look. 2, 2, 6, 6. See the pattern there? All right, so we're going to write -2. We're going to write -6. Let's talk about our A value. A value is from the center to the vertex. Now, because I created a graph, I could just count, right? Or I could say from a y value of 6 to a y value of 13, that would be a distance of 7. 7 vertically. That means 49 is going to go under my y because it had a distance of 7. I could also physically count now. 1, 2, 3, 4, 5, 6, 7. Okay? Let's talk about my b squared value. Distance from center to covertex, 1, 2, 3. So b squared, if I have 3, I'm going to write 9. Again, look how much easier that was with a picture. All right, let's take a look at the next one. This time it's a little different. We're given the vertices and the foci. Let's start with a little picture, okay? 4, 13. 4, 13. That's a vertex. And 4, 3. Vertex. Hey, you know what we can find right away? We can find the middle. 13 to 3 is a distance of 10. Cut that in half. I have a value of 5. 1, 2, 3, 4, 5. 5. A length of 5 is the middle, okay? And you know what? I didn't even take my own advice. I didn't prep my answer yet, so let me do that quick. Prep equals to 1 every time. And I just found my center point. It exists at 4, 8. 8 is the middle of 13 and 3, right? So I'm going to write minus 4, and I'm going to write minus 8. Wait, while we're here, let's use that distance, right? The distance from the center to the vertex we just said was how far? 5. If it's a distance of 5 to my vertex, my a squared value is 25. Wait, this is vertically orientated again, and so a squared goes under the y value because my ellipse is going sort of up and down like that, right? So we're going to write 25 under the y. Let's talk about this focus here. The focus exists at 411 and at 45. Okay, so it's a little bit wider ellipse, that's why, that makes sense, but that doesn't help me figure out my b squared value, right? So guess what? I have to do a little bit of work. I have to go back to that formula. We need our formula. Our formula is a squared minus b squared equals c squared. A squared is 25. We just filled that in. We don't know b squared. C is the distance from the center to the focus. Center to the focus. If my focus is at 4, 5, I can physically count since I drew a picture. That's a distance of 3. Okay? Therefore, c squared is 9. You see how I got that? I drew a center at 4, 8. My focus is at 4, 5. That's a distance of 3. 3 squared is 9. Okay? Now, what we just created is a little equation. Let's minus that 25 to the other side. What do we got here? 16. We're going to divide both sides by a negative, and therefore my b value is 4. My b value is 4. Wait, I don't even need b value though. Look at this. We actually just need b squared. B squared is 16. So 16 is what goes under my x value. So sometimes, depending on the info, you might have to use your formula to find another value. All right, let's take a look at our last example. I know this is a long one. Bear with me. I promise all these examples are a little bit different, and it'll help you with our lessons and with our future assessments. All right, let's visualize this next one with some sketches. Okay, I'm going to start by drawing those co-vertices. Our co-vertices are at negative 10, 8. So I'm right here. And negative 10, negative 16, I'm way down here. That's co-vertices, which means if I visualize my ellipse, it's oriented horizontally, right? Because those are co-vertices. Now, they're still very helpful because they will help us find our center point. So let's prep that so we can fill in those numbers. If I find the middle of those two dots, the middle, I'm going to exist at negative 10. That's guaranteed, so I can write plus 10. But we need to calculate our y value. The distance between negative 16 and 8 is 24, right? 24. And so half of that would be 12, right? So if I'm at 8 and I subtract 12, I'd be at negative 4. Or if I'm at negative 16 and I add 12, I'd be at negative 4. So my middle number is at negative 10, negative 4. So I'm going to write plus 4 for my center. See how that works? Guess what? You actually already knew it was negative 4 because look at this. If I graph my foci, negative 5, 1, 2, 3, 4, 5, negative 4. Oh, we knew the negative 4 already because of our focus I just drew. So sometimes it's helpful to just keep drawing dots because we could have known that negative 4, right? These are my focus, which makes sense, right? We said we're orientated horizontally, so having our focus horizontal makes sense. Well, we need some values here. We calculated the b value already, you guys. We said the b value was 12. B squared goes under the shorter value. The shorter value is vertical. So b squared is 144. That's my minor axis value, so it goes under the y. But as you might have figured, if I know b and I know my focus, I'm going to have to find a. So we got to do a little bit of calculating here, folks. So a squared minus b squared equals c squared. See my previous video for that. My b value was 12, so it was 144. I don't know a. C squared. C is the distance from the center to the focus. We could physically count that since I drew a graph. 1, 2, 3, 4, 5. 5, so 25. Or we could count this. Take a look here. We're talking about the horizontal distance. The distance from -10 to -5 is 5. 5 squared. Couple ways you could think it through, right? All right, let's add 144 to the other side. That's 169. I don't need to square root that because we want a squared under the x value. This would be the toughest kind of problem in our current class that I would throw at you. Of course, if you're in a more further advanced math, we could extend this information further. But I do encourage you to consider pausing, rewinding, and just listening without writing, without worrying, just re-listen. Alrighty, I know this was a long one. Thanks for bearing with me. Make sure, as always, to check out Google Classroom. What's the task at hand? Consider rewatching this, right? Consider listening to this without watching. You know, do something to take in this information. Seek out other YouTube videos. Seek out other teachers if you feel like you need more information. Let me know if you have any questions. And as always, have a good one. See you next time.